On this trip through the digestive system, we study motility, which is the action of muscles of the GI tract that mix and propel its contents from the mouth to the anus. On this page, we will create a table that illustrates the regulation of gastric motility. Think about what you have learned about neural reflexes and GI hormones and answer each question as it appears. You must answer the question correctly to proceed. During the cephalic phase of control, stimuli like the thought, sight, smell, or taste of food elicit a response in the stomach. Will nerves or a hormone mediate the response? Will the neural response involve extrinsic nerves, a long reflex, or only the enteric nervous system, a short reflex? Signals from the brain to the stomach are carried in the vagus nerve. Will gastric motility increase or decrease as the stomach prepares to receive a meal? During the gastric phase of control, distension of the stomach elicits a response. Will nerves, a hormone, or both mediate the response? Neural reflexes are involved, but that's not all. A hormone is involved, but that's not all. Which hormone mediates this response? Note that we use the term neural reflexes when the neural mechanism is not fully understood or when both long and short reflexes are involved. Will gastric motility increase or decrease as the stomach begins to work? With a meal inside it, the stomach mixes and propels the contents. During the intestinal phase of control, distension of the duodenum elicits a response. Will nerves or a hormone mediate the response? Stretching the intestinal wall activates nerves. Will gastric motility increase or decrease as chyme fills the duodenum? Think about the function of the small intestine. During the intestinal phase of control, fat in the duodenum elicits a response. Will nerves or a hormone mediate the response? Think carefully about what the intestinal hormones do and what stimuli cause the release of each one. Which hormone mediates this response? Will gastric motility increase or decrease as fat appears in the duodenum? During the intestinal phase of control, acid in the duodenum elicits a response. Will nerves or a hormone mediate the response? If you chose hormone and thought it might be secretin, you were thinking about how the GI system works. Acid causes release of secretin. However, the reflex is so fast that the response is due to neural activity. Will the neural response involve extrinsic nerves or only the enteric nervous system? It's very fast and appears to be entirely intrinsic. Will gastric motility increase or decrease as acid appears in the duodenum? During the intestinal phase of control, hypertonic solutions in the duodenum elicit a response. Will the response be carried out by nerves or a hormone? The mechanism for this reflex is currently unknown and may involve nerves or hormones that are not yet understood. Will gastric motility increase or decrease as a hypertonic solution appears in the duodenum? Intestinal feedback is collectively called the enterogastric reflex, named for its origin and site of action. This reflex is an integral component of the back-and-forth balancing act between stomach and small intestine as a meal is digested. The thought of food and presence of food in the GI tract regulate digestive activity. The autonomic nervous system can exert control over the operation. What will happen to digestive activity when the sympathetic nerves are activated? What will happen to digestive activity when the parasympathetic nerves are activated? Gastric motility increases when the stomach prepares for and contains a meal. As the stomach empties, intestinal feedback adjusts gastric motility so that intestinal digestion and absorption are maximized. During digestion, segmentation is the primary form of motility in the small intestine. Segmenting contractions are stationary, oscillatory, alternating contractions and relaxations. They mix chyme with intestinal juices and bring it into repeated contact with the absorptive epithelium. A single segment of intestine alternately contracts and relaxes, like these hands alternately contract. Click the hands to see contractions at the normal duodenal frequency. Intestinal segmentation is slow. The frequency varies. It is greatest in the duodenum, about 12 per minute, and least in the ileum, about 9 per minute. The frequency of segmentation is controlled by the interaction between pacemaker cells and smooth muscle cells. Click the duodenum to see segmental contractions. Let's color the contents of the small intestine to illustrate mixing. Notice how effectively segmentation mixes the contents of the gut. Because the frequency of segmenting contractions decreases from duodenum to ileum, there is a slow net movement of chyme along the small intestine. Small peristaltic waves that die out within a few centimeters also move chyme along. The slow passage of chyme through the small intestine permits maximum digestion and absorption of food. The volume and contents of the small intestine regulate the strength of segmenting contractions. Note that it is virtually impossible to exceed the absorptive capacity of the small intestine. Whatever you eat will be absorbed. Click the intestines for a summary. In summary, the type of motility in the small intestine during digestion is segmentation accompanied by limited peristalsis. Segmentation mixes the contents of the tract with intestinal secretions and brings chyme into contact with the absorptive epithelium. On this page, we will create a table that illustrates the regulation of motility in the small intestine during digestion. Think about what you have learned about neural reflexes and answer each question as it appears. You must answer the question correctly to proceed. When a meal is in the stomach and gastric motility increases, neural reflexes act on the ileum. Will the neural response involve extrinsic nerves, a long reflex, or only the enteric nervous system, a short reflex? Will activity of the ileum increase or decrease? During the gastric phase, a hormone also stimulates the activity in the ileum and relaxation of the ileocecal sphincter. Which hormone mediates this response? This is called the gastroileal reflex. Like the enterogastric reflex, it is an example of the activity of one part of the GI tract influencing another. During the intestinal phase of control, distension of the small intestine elicits a response. Will nerves or a hormone mediate the response? Note that we use the term neural reflexes when the neural mechanism is not fully understood or when both long and short reflexes are involved. Will the strength of segmenting contractions increase or decrease as chyme fills the intestine? Think about the function of the small intestine. Remember that the volume and contents of a meal regulate digestive activity. The autonomic nervous system can exert control over intestinal motility. What will happen to segmentation when the sympathetic nerves are activated? What will happen to segmentation when the parasympathetic nerves are activated?